This video is going to cover Unit 27, Section 3, Areas of Sectors. A sector is when you take a circle and you cut it up. It's like taking a pie and cutting a piece of the pie out. That piece of the pie that you take is a sector. So if I have the circle right here and I take this part right here and I want to find the area of that, that is a sector. Now, so let's remember that the area of a circle is equal to pi r squared. So that would be the area of the entire part of the circle, which is 360 degrees. So if we start here and we go all the way around, that's 360 degrees. But if I want to find only part of that area, this part right here, and let's just say that that's 110 degrees. Okay? I'm only finding a fraction of the circle. And that fraction that I'm looking for is 110 over 360. Okay? So the area of a sector is equal to the degrees of the angle divided by 360 times pi r squared. So it's the area of the circle, but only a fraction or a percent of the area. So let's say that we've got this circle here, and let's say the circle has a radius of 8. Okay, so I'll put that there. So we've got what we need here. So the area of this sector is going to equal 110 divided by 360 times 3.14 times 8 squared. That will give me the area of that sector. So we go fraction bar, 110 over 360 times 3.14 times 64, which is 8 squared. Everything's in. So the area of this particular sector would be 61.4 square units. If that radius was in inches, this would be inches squared. All right, so that's how we find, this is our equation, the number of degrees divided by 360 times the area of the circle, which is pi r squared. Now this is very similar, I mentioned this before, it's a very similar use of the area circle as we were finding the circumference. Remember when we had to find an arc length? Remember, an arc length was equal to the degrees divided by 360 times the circumference of the circle, which was 2 pi r. Remember that when we were finding arc length. So this is the same thing. So with an arc length, we were only finding a percent of the circumference, which was the degrees divided by 360 multiplied by the circumference formula. The same thing is happening here. We're only finding a percent of the area of a circle. I mentioned the similarities between these two at that time. I think I did, if I remember right. I should have. But that's how we find a sector. Now let's take a look at page 687, areas of sector. We've got two tables there, figure 27-3 13. Got to bring it a little closer because I can't see it that well. And we have various sectors. We're given two things and we're asked to find a third. So let's just take number 7 for example. The radius is 10 centimeters and the angle is 120. So that area is going to equal 120 over 360 times 3.14 times 10 squared, which is going to be 100. So finding the area of that sector, 120 over 360 times 3.14 times 100. I probably could have just said times 314. That would have taken care of that. So the area of that sector is 104.67 centimeters squared. Well, what if we've got something different, something like number 11, where we're given the area of the sector and we're given the angle and we're asked to find the radius. So let's write that one out. So the area, which is something we know as 750, they give it to us. 750 is equal to, what is that central angle? 180.5 divided by 360 times 3.14 times the radius squared. And what we're looking for here is the radius squared. Well, all right. We can simplify this, but I'm just going to kind of do it the long way, sort of. 750 times the reciprocal of this, which is 360 over 180.5. I'll put a 1 right there, just kind of as a placeholder. And that is going to equal 3.14 times the radius squared. All right, so let me figure this stuff out right here. And then after that, I will divide by 3.14. So a fraction bar of 750 times 360 divided by 180.5. That looks good. And this is 1495.8. And that is equal to this. So what I will do now is I will divide 3.14. And that's going to equal r squared. Remember, this is r squared. We haven't found r yet. So in order to solve this, I take the square root of both sides. So I will take the square root of, and then put a fraction bar inside the square root. And 1495.8, and then in the denominator, 3.14. Look at it. Okay, so that gives me a radius of 21.8. Now I could go back and plug it back in and make sure I get that area, but I feel very confident that I did all of those steps correctly. So this finding the radius, we're just using algebra, and I did it one step at a time. You could, there's several different ways you could do this. You could, at this point, you could take 180.5 and multiply it by 3.14, then take that number and divide it by 360 to get this as one whole number, or not a whole number, but one number, and then divide that by both sides and divide it by 750, and then take the square root. You could have done that way, which is just fine. I just did it sort of one step at a time. I use this. I don't like to do it that way, because that means that I probably would be rounding right there, and I don't like to round too many times until I get to the end. Well, I'm rounding 3.14 anyway, so I mean, what difference does that really make? I guess it's just my petty little way of doing things. So I multiplied it by the reciprocal of that fraction and then divided it by 3.14. And always remember, you've got radius squared on that side, so you've got to take care of that squared by taking the square root of it. And there's different ones. There's ones where you have to solve for the angle. So let's take a look at one of those where we have to solve for the angle. I ran out of room on that page, so I got to get a whole new sheet of paper for one little thing. All right, so let's take a look at, let's see, which one has, I'm looking at number 17. Okay, so the area, I'll write the equation down one more time, the raw equation. Area is equal to d divided by 360 times pi r squared. All right, now number 17, they give us the area as don't do that, 15.882. So that's the area, is equal to, they do not give us the angle, so I will just put D in there, 360, and then times 3.14 times the radius squared, which is 3.273 squared, like that right there. Well, what I'm going to do is I'm just going to go ahead and find out what this is. And once I find that, I'm going to divide it by 360. Or I can just put it right into a fraction bar. And I say 3.14 times 3.273 quantity squared. And put 360 in the denominator. So all of this on this side becomes D times 0.093. And that still is equal to is that 15 point? Yeah, it's got to be 15.882. So divide both sides by this. .882 divided by 0.093, and I get an angle of 170.77 degrees. So that must have been the angle, the inscribed angle. So there we have one example of just finding the area. Then we had an example of finding the radius. Then we had an example of finding the degrees.